Welcome to the VDE America Tech Talk today, July 17th. Today's topic is going to be catastrophic peril, solar risk assessment with a focus on hail. And we're going to be going over the loss estimates that are available from VDE Americas and also our partner, Global Risk Consultants, which is a company you'll learn more about. It's part of TÜV SÜD. Without further ado, let me introduce our speakers. We have Marco Petrilli, who is the managing consultant for Global Risk Consultants, a managing consultant at Global Risk Consultants, excuse me. We also have Ian Liu, who is a client executive at Global Risk Consultants, and also myself, John Previtali. I'm a VP and Senior Principal Engineer at VDE Americas. So welcome, guys. Let me just tell the audience a little bit more about you, and I'll start with Marco. So Marco Petrilli manages the natural hazards practice at Global Risk Consultants. His team has been involved in numerous natural hazard-related loss studies across multiple industries, including those related to renewables since 2010. Wow, that's quite some time. He previously worked as a licensed structural engineer, designing structures for the effects of earthquake and wind forces. He earned his Master's of Science in Structural Engineering from the University of California, Irvine. So welcome, Marco. Thank you. We also have Ian Liu. Ian Liu is a client executive with Global Risk Consultants. He serves as client relationship manager for a primarily power generation and renewable energy book of business, and helps the risk engineering team in the prospecting, engaging, execution, and delivery of fire, boiler and machinery, natural hazards, infrared thermography, and asset valuation services. That's quite a range. Ian is a RIMS conference speaker and a thought leader in the risk engineering industry. He previously worked with FM Global and AXA XL in property risk engineering and property underwriting roles. He earned a Master's of Management in Artificial Intelligence from Queen's University and a Bachelor of Applied Science degree in Chemical Engineering with a minor in Sustainable Energy from the University of Toronto. Welcome, Ian. Great, thank you.
Thanks, John.
Excellent. Well, let's get started. So here's what we're going to talk about today. We're going to learn a little bit more about, just briefly, VDE Americas and Global Risk Consultants, GRC. I'll talk just briefly about the hail risk intelligence for solar services that we offer, and then we'll get into the meat of the presentation, which is going to be talking about GRC's natural hazards loss report for solar and hail loss estimates for solar that are provided by VDE Americas. And then we'll talk about how these loss estimates inform insurance coverage and pricing, and then we'll have questions. And feel free to type in your questions just along the way, and we'll try to answer them as we go. All right, so who is VDE Americas? Well, we are a division of a large organization that was founded actually in the late 1800s by Werner von Siemens in Germany. VDE, the VDE mother organization, is dedicated to ensuring the safety and reliability of all products that are used on the grid in Europe and thus throughout the rest of the world. But in the United States, we're a group of engineers who really focus on technical advisory services for the solar power industry. We've done a lot of work on utility scale solar projects and energy storage projects, also community and C&I solar. So we've supported over $15 billion in projects that have been financed and are operating over the last 12 years. We provide owner's engineering and independent engineering services. So for instance, owner's engineering for banks and developers, independent engineering and support of deal teams. We also provide technology reviews of things like inverters and PV modules, solar panels. And then finally, we have a niche in the sense that we are the industry leaders in assessing hail risk and also providing mitigation services consulting services for hail for the solar power industry. And then just very briefly, what sort of hail services we offer are site and equipment specific weather analysis, probable maximum loss reports or just loss reports, as we're going to be talking about today. We help with pro forma risk exposure for hail, so both like the P50 and downside like P90 and P95 exposure loss estimates for hail. We have a set of maps that are very useful for people to understand hail risk at a particular location very quickly, given the type of equipment that's being used, whether it be the type of PV module or the type of tracker. In fact, this map that I'm showing here is an example of one of our maps. We support with insurance optimization to ensure that there's not too little, not too much coverage for hail, portfolio risk management, hail monitoring and stow protocol assistance. We can help you set up hail monitoring and stows, which are really the best defense against hail. And then we work with our sister organization, the Renewable Energy Test Center, or RETC, to provide actual testing of PV modules. We have a new test called a hail resiliency curve test. That is really a much more advanced test than the typical IEC 61215 standard that can really tell you how modules will perform in real world conditions across a whole range of hail impact energy levels. And then finally, we have a new service that I'm doing a soft launch of, an announcement. It's a hail stow verification service where we'll ensure that project trackers are actually going into hail stow when they should be, based on meteorological data we get from the National Weather Service and also data we get from the actual tracker to ensure that they're going into hail stow when hail is nearby. Or so this, we're hoping, what we know is going to be very useful for insurance providers and also obviously owners and operators and financiers who want to ensure that the hail monitoring and stow systems are working properly. Okay, let me hand it over to Ian to talk about global risk consultants. Ian?
Thank you, John. One of the biggest similarities, and I would say one of the key factors that we share between VDE Americas and GRC is our concept and approach of being independent. And that's really one of the biggest factors that really brought us together in this strategic alliance. We're one of the world's largest, if not the largest, independent and unbundled, meaning unattached from any insurance carriers. We're one of the largest independent property risk engineering providers for many topics or for many engineering domains. Not only do we specialize in natural hazards, the bulk of our work that we do for our global clients also include things like fire protection, equipment breakdown, or boiler machinery hazards. We have a big group in electrical protection, project valuation services, and we have a wide range of projects and project support and diversified services as well. And we are also part of a larger German conglomerate. We're part of TÜV, which is, as of 2010, we're part of TÜV, which is one of Europe's largest inspection, testing, certification companies in Europe, based in Munich. And TÜV also have a very large presence in Asia Pacific and also in the Americas as well. And we partnered up with a lot of the large size, we would say 20% of Fortune 500 companies, which choose GRC as our independent, unbundled loss control partner. And we try to develop a very long-term, meaningful relationship with our clients, and especially within our natural hazards practice, which Marco leads. I think over the past few years, I think our efforts are we spend about up to 50% of our time and commitment are for our clients in the energy transition and also renewable energy space. So that's a significant effort, from both sides of the house over here. And I'll pass this presentation to Marco, who leads our natural hazard practice.
Thanks, Ian.
Great, thank you very much, Mark. Ian. Yeah, Marco, you want to talk about this slide, PML?
Maybe let's go over some terminology first. I think, regarding the differences between deterministic and probabilistic risk assessments. So, one could do a scenario-based assessment that would be considered deterministic. So, for instance, you can consider a Category 3 hurricane making landfall at a specific location along the Gulf or the Atlantic coastline. Or perhaps maybe it's a hailstorm, event, occurring over a specific area, producing a maximum hailstone size of, say, 3 inches, right? Those are all considered scenario-based assessments. Now, a probable maximum loss, or PML, as some of you know, is an assessment that is probabilistic in nature. So what does that mean? We're simulating, many potential events that are likely to occur, and we utilize that information to create the hazard. Now, there are varying definitions that I've witnessed over time for what a PML is, but here are a couple that I chose for today's presentation. For those of us who are familiar with fire loss prevention, right, PML, that could mean the largest credible event under an adverse but realistic condition, meaning a single fire protection system being out of service. From my background in earthquake risk assessment, a PML, that tends to be either an expected or an upper loss estimate, in other words, a P50 or P90, and typically done for a 500-year event. Now, I'll let John go in further detail later in this presentation, but for VDE, they defined a PML, which tends to be the median loss, or P50, and for common return periods, such as a 100 or 500-year event. Most times when I am approached by new developers requesting a PML study, I come to find that the ultimate goal here is to obtain an alternative to CAT model loss estimates. So, given the varying interpretations of PML, I think we should maybe reconsider using the term PML and maybe instead focus on an engineering-based assessment, that's associated with return periods and percentile estimates that are of interest to everybody, including the key stakeholders. Next slide, please.
Excellent. Thank you. Yeah. Okay. So now I think you're going to tell us about the GRC Natural Hazards Loss Report.
Yeah, let's go over in brief detail. All right. So, the natural hazard practice, we provide loss and loss prevention products for various industries. But most specific to today, we provide engineering-based assessments associated with natural perils of earthquake, named windstorms, flood, wildfire, and severe convective storms for utility scale, solar, storage, and wind projects. Our assessments rely on a review of project-specific drawings, calculations, and reports. Sometimes we perform site surveys for clients that are interested in a more comprehensive assessment. Depending on peril of interest, we perform either deterministic or probabilistic analyses to estimate our loss estimates. That's where you see your P50 and P90 events. Presently, we're doing this now for site-specific assessments, and we also do it for portfolio-wide assessments. In general, we're trying to support the financing and insurance needs.
That's great. Marco, I have a question for you. So
yep.
How does a client, or how do you, or perhaps an insurance consultant, determine which CAT perils should be included in a report like this? Or do you just include all of them?
No, I mean, we can include all. It's just a little more time consuming, being that this is engineering based, so we're reviewing a lot of information. So usually we work with the developers to determine which perils are of most concern, right? And they're probably working with their insurance carriers or the lenders to determine what those are. And we'll try to focus on those.
Okay. And so are the project developers typically your clients?
Yes, correct.
Okay, great. Excellent. Okay, great. And I understand, so obviously this being a topic, or this seminar being mostly about hail, we're going to talk about severe convective storms, which generate hail. So Marco, could you tell us more about the details of severe convective storms?
Yeah, definitely. So what we try to focus on or analyze are various hazards, right, which include downburst, otherwise known as straight line winds, tornadoes, lightning, and hail. Tends to be the three large perils occurring simultaneously sometimes during a severe convective storm. While the likelihood of all four occurring simultaneously may be unlikely, we conservatively take a 90% sum of the losses for property damage, and we tack on the controlling business interruption loss in order to derive at an overall severe convective storm loss. For a majority of solar projects situated east of the Rockies, the controlling hazard clearly tends to be hail, which is a key vulnerability to PV modules. And that's probably followed by the downburst or tornadic winds, affecting the PV modules and the supporting single tracker system.
Okay, great.
Stowing and obviously, business interruption are things that we focus on when we look at these.
Yeah. Could you elaborate on what a controlling hazard is?
As I mentioned, right, we're going to have the clear of the three hazards that we usually assess. You're going to have the clear the key driver to the losses, right? So as most of us are here in this call today because we're all subject to some level of hail risk, and that tends to be the largest driver to losses for solar projects, especially utility scale sizes. So really the focus is, as John, some of your atlas maps show, right? Where are we in the country, and are we talking about solar? And yes, right. So that's the focus here. It's what kind of hail damage are we looking at?
Okay.
First and foremost.
I see. So a controlling hazard is like the biggest hazard in a particular location out of all the cat
Correct.
I see.
Yeah.
So in California, I think you mentioned during our prep call, like seismic or earthquake is the controlling hazard.
Definitely, by far, yeah.
Interesting. Great, thank you. All right, downbursts.
All right, so we rely on the latest credible sources for natural hazard mapping. In the case for downburst winds, we rely on the 2022 ASC 7 standard, which provides us P50 wind speeds for the US. Now we further rely on regional wind data to establish a P90 level wind gusts. The assessment level winds we compare those to the speeds used for design, and we account for site-specific exposures and design load factors. Right, panel to tracker connections, automatic stow procedures, those are all considered when we come up and estimate our loss estimates. Interior versus exterior rows, right, and the shielding effect of those, so that's all considered in what we do.
Okay. Yeah, interesting.
Slide.
Great. Just one question about the interior rows versus exterior rows. I understand that exterior rows are more wind resistant than interior rows for trackers. Is that your understanding?
Correct.
As well?
Yeah. So the foundations, the piles are designed for higher wind loads. So in the anticipation that they're going to have unshielded exposure to direct straight line winds, whereas the interior ones get some sheltering effect from the perimeter, outer rows.
Yeah, and that's to avoid. I see it listed here, torsional galloping. That's where the tracker starts twisting around and then twists itself apart.
But yeah, and that's more to do with stowing it at a flat angle, right? At 0 degrees, where you get this undulating effect, and you get the torsional galloping. So usually what you're looking at when you get wind speeds that exceed a certain threshold, the tracking system would start to stow, and providing a wider surface for wind to then apply its pressure on. So it increases the demand on the piles, the supporting piles. However, the goal here is to eliminate the torsional galloping effect, which is a serious concern.
Yeah. And is it true that most, like some trackers, they'll stow, they'll wind stow at a high angle, and then some will wind stow at a flat angle? It's like
I mean the goal is
categorically there's a big difference, right?
Yeah, you're avoiding the 0 to 15 degree angle sort of range, right? You're getting a steeper angle, increasing the wind. However, the supporting structure is designed for that increased wind.
Yeah, interesting. Which costs more if it's at a.
Which costs more, but ultimately avoids torsional galloping issues.
Yeah. So you want to pay more for the stronger structural system to allow for that wind stow at steeper angles. It's also good for hail. Yeah.
Yeah.
Okay, great. I'll move on to the next slide. tornado.
Tornadoes. In the case of tornado winds, we rely on the National Institute of Standard Technologies. They have a technical note. I think it's 2242, which was used to develop the tornado wind speed maps for building design in the U.S. What this technical note provides, it's a handful of maps for different construction footprints and various return periods. Now, since we don't have the statistical data for development of those maps, what we do is we estimate the P level 90 wind gusts. Again, similar to hail, the most credible, tornado risk would be, east of the Rockies. When considering a 500-year event for a typical solar, project footprint. Now, while wind projects are not required to be designed for tornado winds, they are, and it should fare well for EF0 level wind tornado events, because the wind speeds tend to be generally less than code prescribed straight line winds. Now, as you start getting to areas where a 500-year EF1 is credible, that definitely can cause very localized and intense damage to solar projects. Just given that those wind speeds would be in excess of the straight line wind design loads. And obviously there's also an accompanying, windborne debris field.
Yeah, that makes sense. Are there any, do we ever see solar power projects designed to withstand tornadoes?
Not to my understanding. I mean, even for buildings, you're looking at hospitals and police stations, that type of occupancy before you start designing for tornadoes.
Yeah. And does your model take into account swath width of tornadoes?
Yes. Yep.
Yeah.
Swath direction.
Yeah.
Sure.
How do you come up with the swath width, or is that a secret sauce?
No, it's just based on historical events. Figuring out what a typical EF0 and EF1 might have in width and length, right? So you can make use of that. They typically occur from southwest to northeast direction. So again, you could overlay that kind of path over the project and get a sense of idea of the maximum potential loss.
Yeah, interesting. So there's really nothing that people can do to avoid damage from tornadoes. They just have to sort of prepare for it.
Yeah, I think when it comes to design for it, you're looking at emergency shelters, right? First and foremost, as well as life safety. But the design of structures themselves, you can design for higher winds, but again, at a higher cost.
Yeah, interesting. Great, thank you. Lightning.
All right. Well, lightning, that lightning protection tends to be a design consideration for most components in a solar project. So, potential losses here tend to be nominal. While there are no statistical data to develop probabilistic maps, GRC relies on the National Lightning Detection Network, their maps and their annual flash density counts to just determine if the hazard would be considered, below, above, or average when compared to the balance of the country. But the loss estimates, they need to be an annual loss estimate.
And do you think that when you say nominal, it sounds like lightning isn't a big source of loss? Is that a fair assessment?
Correct. Well, yeah, I think, while the path is there to ground, lightning strikes, and certainly you got the, other means of minimizing the potential risk, right? There's always that possibility that something may go wrong or something was not properly installed, and you might get some localized damage.
Do you feel like it's not a big source of loss because the equipment is properly protected and it's struck by lightning and it's not damaged, or it's just
right?
Okay, interesting.
Certainly in high high areas of high lightning density, towards the eastern side of the U.S., you can definitely have a lot of lightning strikes, and it's a matter of, do we have a direct path to grounding to get that energy, out of whatever it's striking and causing some sort of damage or even fires.
Interesting. That's good to know. Okay, hail. So I'm going to take this one, unless Marco, you have anything you wanted to mention before I jump into it.
No, I mean, no, obviously VDE, this is what you do. I just want to let you guys know that, GRC does continue performing the hail assessment for the balance of the project. When it comes to the modules, this is John's domain here.
Yeah, excellent. Yeah, and yeah, we're really excited to partner with you guys and provide the hail risk assessment and loss estimates into your report. So first of all, yeah, thank you very much for your collaboration. Really happy about that. And we have produced our first few reports for some lucky customers. And I think we've gotten pretty positive feedback so far. So yeah, I'll just talk about the hail probable maximum loss and annual average loss analysis, or just in general the loss analysis. So yeah, we with regard to the frequency of hazard, we define events by the 95th percentile maximum naturally occurring hail size. And so when you hear about a hailstorm that is say like a 45 millimeter hailstorm or 65 millimeter hailstorm, that means that the maximum diameter, Dmax, as it's called clinically, is the 95th largest hail size in that storm. So there are a few hailstones that are larger, and then there are many that are smaller. So that's one thing to note, is that we take into account the whole size and spatial distribution of hailstones within a storm when we're calculating probable maximum loss and also average annual losses. So it's not just like a storm with a consistent like 65 millimeter hailstone, only 65 millimeters. It's like a whole bunch of different sized hailstones. So it's pretty hard to model, but we are able to do that using the data that we get from the National Weather Service. We also look at the return interval, as you would expect, of years by the hail, what we call bin size. And so out of that huge distribution of hailstone sizes, we put them into bins like all above 25 millimeters, incidentally. So 25 to 30, 30 to 35 millimeter, and so forth. And then we look at the actual return interval, so the chances of having a bin of those hailstones within a given time frame, like 1 in 25, 1 in 50, 1 in 100 years, and so forth. And then we add those all up to get like essentially like a storm level return interval. We also include annual, what are called warning days and hours. So how many days? These are metrics that are commonly used by the insurance industry. I think it was they typically get them from a company called Swiss Re. So it's a metric that gives you a sense of like how many days per year you're going to be warned for severe hail, and how many hours per year you're going to be warned for severe hail. We also include both yearly, so seasonal hail risk assessments. In most areas, the hail season starts around May, and then ends, like in September. And there's sometimes in some areas there are 2 hail seasons, which is crazy. And then diurnal patterns. Most of the time, hail occurs in the late afternoon and early evening, but you don't want to be lulled into a sense of security outside of those hours, because some of the worst hailstorms that we've seen recently, like for instance, the one that decimated Fighting Jays, happened at around 2 to 3 a.m. Local time. We also show in our report the co-occurrence of hail with different wind speeds, both at the P50, so like the median, and also the P90, like downside levels. So that's very interesting for understanding. In my opinion, it's very interesting for understanding the strength of wind stow that needs to be maintained during hail events, hailstorms. We look at damage thresholds in the form of impact energy from hail. We have a specialization in understanding the resiliency of PV modules based on their construction and also their dimensions. So I'll talk about that a little bit more in a moment, but different modules have different resistances based on the type of glass that they use. And then, of course, we also look at the damage based on the tracker angle. So hail stow, as I mentioned earlier on, is essentially the best defense mechanism against having damage. So being able to put the trackers into a high hail stow angle is incredibly advantageous. With regard to the financial metrics that we provide, we show probable maximum loss, which, as Marco mentioned briefly, is the median maximum loss over a 500-year period. So it's not necessarily like it's a little bit, the term is a little confusing. So it's not the worst case scenario that you could possibly have over a 500-year period, but it's actually the largest probable maximum loss. It's the largest loss that is likely over that period. We also show average annual loss, which is just basically an estimate of the loss on a year-by-year basis. We show a business interruption loss that takes into account lost revenue over 6 and 12 month periods, and then obviously we can combine those losses for assessment of sufficient property insurance coverage and also business interruption insurance coverage. It's also useful to show risk comparisons of different locations. So we'll take the project that we're analyzing, and we'll compare the results. We'll show the results to you in terms of what they would be in California, which is a very low hail risk area, and also West Texas, which is a very high hail risky area. And then we finally will show extreme downside scenarios that are useful to some clients who are extremely sensitive to risk and who would rather who want to essentially understand the bookend of probable maximum loss at a downside level. All right. Let's talk a little bit more about hail. Go ahead.
John, I think there are two questions in the chat. Maybe we want to address them before moving on to the next section.
Yeah.
I think the first question, we'll probably be able to address that in the loss quantification slide coming up. I think it's there's one question asking about the sort of a typical loss scenario for a 68 versus a 75-degree stow scenarios. We probably will be able to address that in the loss quantification slide. I think as will be coming up in a few slides. Also, there's another question. I think the first question was, are we seeing positive trends in thin film and crystalline modules, hail resistant by design or test results? I wonder if we'll be able to address that maybe towards the end of or you feel if you wanted to address it now.
Yeah, sure. Yeah, I can. Yeah, let me address those. So yeah, as you mentioned, we'll go into more details in a moment. But yeah, 75 degrees makes a huge difference compared to 60 in the most hail-prone areas. And then we are seeing positive trends for crystalline modules and thin film. So companies like for solar, for thin film, also Trina, Jinko, Helene or Helion, they're designing and offering what are called hail hardened modules. And so in all cases, it's basically using glass that's thicker and fully heat tempered to harden the module. And then there's also some special stuff that First Solar has been doing around improving the resiliency of hail around the edges. The edges of modules are the most fragile when it comes to hail and can be cracked the most easily. Okay. Yeah.
Thanks, John.
Great. Yeah, you're welcome. Okay, so what I'm showing here, actually, this crazy animation is a hailstorm. taken by a GOES satellite. So it's like a geosynchronous orbit satellite that takes images of North America. And this this hailstorm, I believe, was in Georgia. I don't remember exactly when, but it produced grapefruit-sized hail, according to Wikimedia, where I got this image. So it's really crazy looking. You can see the land sort of moving to the side. So the image is synchronous with the hail storm, which is moving across the landscape. So you can see sort of like the land moving to the side. So, I mean, this is such a powerful thing, these hailstorms. Okay, so I stole this slide from KWH Analytics, who we did a tech talk with a few weeks ago. So thanks to them. They're also a great partner. They provide property and casualty insurance, including for hail. And they noted that hail accounts for 73% of the losses by dollars, but only 6% of losses by count. So what this says is that we have very few but very large hail loss events happening in the solar power industry. So yeah, like looking over just a few more statistics here, we've had about $1.5 billion in solar related hail losses between 2012 and 2025. So I just wanted to sort of like provide a magnitude of the problem here. So how do we go about assessing hail risk? Well, we start with radar, and this is a great benefit using radar from the National Weather Service because we oftentimes, for other hail risk assessment services, including, unfortunately, FEMA, they use claims data and also data that is derived from a network of spotters. So actually people calling in information about hail that they observe. And that causes what's called population bias. And so the issue is that you'll see with population bias, you'll falsely see more risk in areas where there are people, like in cities and whatnot. And the areas that we put solar power projects on are typically very remote locations. And so you really need to use radar in order to understand the hail risk, as opposed to just historical claims data or spotter data. So the image that I'm showing here is actually a image of what's called the reflectivity of a storm from the NEXRAD radar system maintained by the National Weather Service. And then what we've done here is we've used our software to identify the location and the size of hail as it's being produced by this hailstorm. And so this is just a visualization of what we do to capture the historical hail risk for an area. We'll do this for as many storms as we have in our data set. The data set goes back 20 years for radar. Actually, a little bit more than 20 years now for radar. We'll look at hailstone sizes all the way from 19 up to over 100 millimeters if we have that in the data set. We'll also consider the density of hail, not derived from radar, but derived from empirical studies from particularly a scientist named Andy Hainsfield, who's done some great work in the area. We'll also consider shape factors, so spherical to oblate spheroid, which are basically like egg-shaped, longer hailstones. And then we'll also consider terminal velocity. So basically the velocity of hail as it's being blown by wind. Interestingly, the terminal velocity of hail is actually greater than typical terminal velocity because it is being pushed by wind. And then the other thing that we'll do is, we won't just look at a the small area around the project location, because typically we don't have enough data historically for just the project location. So we look at a 100 by 100 kilometer area around the project location, and then we'll focus it down to a 4 by 4 kilometer grid around the project location using an approach that's called dithering. So it's basically like focusing in the data statistically into this 4 by 4 kilometer area. And that'll give us the ability to understand the frequency of data, both over the course of the last 20 years, but also over the course of the future. So, 100 years, 250 years, 500 years. We use an approach in probabilistic modeling called extreme value theory. It's a variation of extreme value theory, actually, to forecast out the chances of hailstorms of different Dmax sizes, as I was talking about before, occurring at different areas. So what I'm showing here are two images. One is like a typical image showing the observations of hail of different size around a project location. And then the other image here is a chart that shows the return interval. So the chances of having at least one hailstorm in a given period over naturally occurring hail sizes. So this is really where the rubber meets the road. I'm showing actually 3 different locations. The blue line represents a low hail risk location in California. The green line represents a moderate hail risk location in Ohio. And then the red line represents a high hail risk location in West Texas. And the way this works is that if we're worried about, say, like a 45 millimeter naturally occurring hailstone, which is where we, begin to see a lot of damage, particularly with 2 millimeter glass modules. What we can say is that in California, we don't have to worry about it because this is incidentally a logarithmic scale, because you would only expect a 45 millimeter hailstorm once in about every 800 or 900 years. So very low frequency. Whereas in Texas, this is 10 years, you would expect it once in like 8 or 9 years. Whereas in Ohio, you would expect it in once in about every 20 years. So this is where we get the return, we derive the return interval that we use for the probable maximums. What else can I tell you? Yeah, we use confidence intervals and uncertainty bounds based on empirical analysis. And then we also use factors, essentially like scaling factors to, as I was talking about before, to dither the data from a 100 kilometer area down to a 4 by 4 kilometer area. The other thing I mentioned, and this relates to the question that someone asked. The other thing I mentioned is that we have what are called hail resiliency curves for specific types of modules. And what I'm showing here is 2 hail resiliency curves. One for a 2 millimeter front glass module that's shown in orange here. Another one for a 3.2 millimeter front glass module that's shown in green. And what I'm plotting here is the probability of glass breakage compared to the kinetic energy of impact on the bottom, and also the freezer ice ball size that's used for laboratory testing up on top. And as you can see, the green resiliency curve for the 3.2 millimeter front glass module is on average about twice as resistant to hail compared to a 2 millimeter front glass module. And the reason that isn't because just the module is thicker, has thicker glass. It's actually because 3.2 millimeter glass can be fully heat tempered under mass production, mass glass manufacturing scenarios, compared to millimeter glass, which can, be heat strengthened, but not fully heat tempered. And you can actually see, I wish I had a picture of it, but you can actually see when there's glass rupture, as it's called, in a module due to hail, the glass pattern is very different between semi tempered or heat strengthened glass and fully heat tempered glass. The fully heat tempered glass cracks like you would see like a car a windshield crack or like a car window crack that is heat tempered. It has lots of little squares of glass that crack like cubes, whereas the semi tempered or heat strengthened glass cracks with very long sort of like almost like spider web like cracks that emanate from the area of impact and go outward. So you don't see that sort of like cubic effect. It looks very different. And
John, is it where you're looking for maybe like a shard, right? More like a shard?
Yeah, like they're more shards, yeah, for the semi heat tempered semi or heat strengthened semi tempered glass. Yeah, thank you. Yeah, as I mentioned before, we also have a way of converting freezer ice balls into naturally occurring hail using that work by Andy Hamesfield. We take into account the angle of impact. This is an area of ongoing research, actually modeling the effect of glass rupture or of hail impact causing glass rupture at different angles is incredibly complex. It's, we use the cosine squared relationship because kinetic energy being 1/2 mass times velocity squared. So the change in velocity follows the cosine rule, but since it's kinetic energy, it's squared. But what we're learning is it's more complicated than that. And so it's somewhere in between cosine squared and cosine. So more to come there, but we are confident that our results are incredibly valuable right now, but we're just constantly calibrating our approaches to make them better. And then as I mentioned, we take into account the glass thickness of 2 millimeter, 3.2, or for solar glass, and also the dimensions in our modeling. And the result is, a big difference in the effect of the loss estimates of hail at different tracker angles. So what I'm showing here is a 500-year probable maximum loss estimate for 3 different locations: a California location in blue, a sample location, which is in Texas, incidentally, and also our Texas reference location in gray. Sample solar location is in orange here. And you can see that, at 0, 10 degrees, and 20 degrees, in this case, I think this is like a 100 megawatt, around a 100 megawatt project. You have around a, 35 to 37, 38, 34 to 37, $38 million probable maximum loss if you don't have stow, right? But if you get it down to 62 degrees, which is Array Technologies standard stow angle, you have less than $20 million probable maximum loss. So this starts to be within what insurance sublimits for hail is, or are, excuse me. 60 degrees is Next Tracker and Game Change's standard angle. So you're getting down to just above $10 million. And then we're also starting to see products from both Next Tracker and Array that are around 75 or 77 degrees. And there your loss starts to become very small. So less than, in this case, less than $2.5 million. All right. So how are hail losses used by
John,
insurers? Yeah,
John, sorry to interrupt you. I think we have at least four questions in the chat, and 2 of the questions are, I think, somewhat related. And Marco, maybe this time around I'll divert a question to you. One of them is, these 2 questions, the way I think they're related because it goes outside of hail damage on just the PV panels themselves. So one of the questions, what are our considerations for hail loss on the balance of the project, which is not just PV panels? And also on the related note, another question is, can we prepare a hail and tornado combined base PML analysis? I guess that question is open to John as well.
Yeah. Yeah, you can do hail and tornado only. Presently, we're looking at all 4 perils occurring, but we can definitely focus on just 2. The other one you said is the balance of project hail vulnerability. I mean, you're looking at your inverters, you're looking at maybe BESS units. Those things can get dented up, not a big deal, right? Doesn't interrupt production of power. Now, what is maybe more sensitive to hail strike could be some of the ceramics that you'd see in substation, right? That's supporting all the overhead bus work. So those could be, vulnerable to a hail strike that could cause, partial collapses on those buses. Similar in transmission line systems, right? You still have those ceramics, even though a lot of them now are strengthened, but those can also are vulnerable to strike. So there's small target areas, right? So the likelihood are somewhat small, and therefore the loss estimates for 500 tend to be somewhat small. But those are certainly some components that are vulnerable to hail strike, aside from the tracking the modules themselves.
Right.
Yeah.
And John, would you like to take the other 2 questions?
Yeah, sure. So I'll take this one from Sukanya, probably to Sai. Thank you so much for asking this. Is how is the impact energy determined given the varying chaotic wind speeds and directions generally accompanying hail events? Yeah, great question. Yeah, thanks for making that point. So, so far we haven't figured out a good way to predict the actual direction of wind when hail falls. It is a very chaotic scenario, and oftentimes we see a change in the direction of wind when hail falls because of the falling of the hail. It seems like there's a shift in the direction of the wind oftentimes. So currently what we do is we just provide bookends. We provide hail loss estimates, assuming the modules are facing into the wind, and then hail loss estimates assuming that the modules are facing out of the wind. And the hail loss estimates facing into the wind are more conservative, so they're larger estimates of loss than facing out of the wind because of the effect of wind causing the hailstones to fall at an angle. If the modules are facing out of the wind, the angle of incidence of impact is going to be more acute. So it's going to provide less of an impact than if the modules are facing into the wind. But we have a ton of wind data that we downloaded from the National Weather Service before, just a couple days after DOGE threatened to start selling it. And so we have like about 2 terabytes of data, of detailed wind data with hail falling at the same time. And so we're looking into trying to predict, do a better job predicting the direction of wind, the probability of direction of wind when hail is falling. So we can have a sort of a more accurate loss than just like the worst case scenario, which is into the wind, and the best case scenario, which is out of the wind. Hopefully that answers your question. And Ian, what was the other question you wanted me to hit?
I think the other question, we do have quite a few other questions in the chat. Also, I'm aware we're almost at the top of the hour. I know we have one more slide to go.
Okay.
Do you want to take the questions, maybe 1 or 2 before we address the next?
Yeah. I'll just like throw in my 2 cents about hail damage for balance of plant. As Marco mentioned, it's minimal compared to the modules. I mean, we do see a little bit of damage. We see damage to things like antennas on the tracker systems, meteorological sensors at the weather stations and whatnot. But like really the main thing that we're concerned about, and the main main source of damage is the modules. Yeah. So the rest of the plant is not really susceptible to major losses due to hail.
Mhm.
Yeah. Okay, let me go to the next slide. So how are hail loss estimates used by insurers? So yeah, so there's a lot here. So let me just go over them briefly. And yeah, Ian or Marco, feel free to chime in. Ian, I know you have a lot of experience in this area. So probable maximum loss and average annual loss metrics are used to inform coverage limits, to determine adequate coverage levels, also sublimits, and also to guide excess umbrella policy needs. Premium pricing, PML is used to inform the pricing of insurance premiums, and base rate calculations, and risk adjusted premiums by location, and also multipliers for different coverage tiers. Deductible structure, average annual loss is usually used to inform deductibles. There are higher deductibles for higher frequency perils. So the more losses you would expect at a particular location, the higher deductibles you would have. There's also percentage versus fixed loss dollar amounts, and obviously separate deductibles by peril type. Also risk transfer decisions. So PML and AEL, the ratio indicates loss volatility. So basically, like what the chances of PML versus like a very large event versus the average annual events are suggest the volatility of losses in a particular area. Also, some companies use this information for self-insurance and also additional layers of coverage like parametric insurance. And then finally, for project financing, I mean, this is where we typically see the use of the PML reports. So lenders and tax equity investors require probable maximum loss or loss reports in general to ensure there's sufficient insurance coverage for specific perils for their projects. Obviously, to also understand the location-specific risk and equipment vulnerability of the equipment that's specified for the project. And finally, they use it to look at the total risk exposure for their portfolios. Ian, do you want to jump in with any other thoughts on that?
No, I don't. I think you covered it pretty well. I don't really have much to add.
Okay, yeah.
Thanks, John.
Excellent. All right, we're pretty much out of time, but are there any other final questions that people want to chime in on?
We do have a few. We do have a few in the chat.
Okay.
I think I attempted to address one of them that both of us will be able to address hail or severe convective storm outside of the U.S. But there are quite a few other questions that are open. One of them is actually directed to RETC. Do you want to take that?
Yeah, could you read it for me? Oh, here it is. I found it.
Yeah.
What is being done to enhance the module breakage curve plot that is generated by RETC? There are new glass compositions on the market that do not fit the 2 or 3.2 construction. Yeah, it's a great question. So we have a new test. It's called the hail resiliency curve test, and it's a Weibull test of failure. And so what we do is we'll take in 30 modules or a pallet of modules, 25 to 30 modules, and then we'll test each one of the modules at an increasing level of kinetic energy using an increasingly larger and larger sized freezer ice balls with higher increasing velocities until each module breaks. If the module does indeed break, we can go up to an 85 millimeter freezer ice ball. So it most likely will break eventually. And then having that test to failure data for this large number of modules, which incidentally are randomly selected, we're able to plot the hail resiliency curves that I was talking about before for these new modules with thicker glass and different constructions. So it's a much more accurate test than the IEC 61215 test, or even the hail durability test that RETC currently offers.
Mm-hmm. think one question you may have already addressed that when you were discussing the earlier question about impact energy. This question is, how would the PML change if the tracker is facing away from the wind in various stow positions? I think you may have already addressed that.
Yeah, it's much better. So yeah, it becomes de minimis in many cases, facing away from the wind, meaning that they're, at least the model that we use does not estimate any damage. So I would say on average, it's probably like, it's about, as you would expect, it's about the same when there's no tilt, right? When it's in the flat position, it's the same. But as you tilt the module away from the wind, it becomes much better than facing into the wind very quickly.
Right.
It varies depending on location, because each location has like a different size and spatial distribution of its probable maximum loss hail event. So it'll be different based on the hail risk at a particular location.
Right. Thanks, John. Just one more question on the same page, our ETC slide that we just looked at. There's one question to say, just want to confirm the 3.2 millimeter glass curve in the graph is heat tempered, correct?
Yes, it's fully heat tempered.
Okay. Right.
That's right.
Yeah, and one question, maybe a shared question, will the recording of the webinar be shared afterwards? I know this is, I think I see the recording button is on, so I want to confirm.
Yes, it's being recorded, yes. Yeah, it will be shared afterwards.
Yeah. If there's any outstanding question that we haven't been able to address, please let us know. I think I've tried to give a thumb up to every question that has been addressed, but if there's anything that's missed, please do let us know. And as John Schiff mentioned, the recording of this session will be made available shortly after.
Yeah, the recordings are available on our website. Yeah. Excellent. All right. Well, thank you very much, everyone. And thank you, Ian and Marco from GRC.
Good, John.
Excellent. Thanks very much.
Thank you, everybody. Thanks for joining us.
All right. Take care.